Hello. In this movie, I'm going to explain about how to create a linear regression, quadratic regression, and cubic regression using Excel spreadsheet, and in how to do it in the Geogebra, and also how to do it in Desmos. Okay, first, we have some certain number of set of data here, and I'm going to have a linear regression. So go to insert and try to draw the scatter plot like this. Okay. To find the line of best fit, just click this, right click on this one and add the trend line. And here, this line is the line of the best fit or the best linear regression line. To show the equation of the line, you can press this choice that the display equation on chart, mark this one. And also you can find the R-square value as well by clicking this. Okay, so this is the best line possible. Okay, without using the graphing feature, you also have like this LINEST function to actually find the equation of the line of the best fit, which is like a LINEST. And you want to plug in the known y values. So you want to put the y arrays, and then you want to put the x values. Then you want to get the slope of the line and the y-intercept of the line at the same time. Okay, now let's move on to the quadratic one. It's very easy to change into the quadratic curve using the format the trend line. And instead of using a linear model, you want to choose a polynomial model. And the polynomial of degree 2 is a quadratic curve. Okay, and you can see the best equation here as well. Okay, so this is going to be the best curve, best parabola that will be closest to the set of the point here. You can also find, well, this is a linear case. In the quadratic case, you can also use a LINEST function. You can press like this, and you can press this, but instead of just finishing at this point, you can press like the hat, and use a set notation. And hat with set notation, you got to put 1 and 2 for the linear questions and the quadratic questions. And you want to get this. Okay. So by this one, this indicates the quadratic term, and this is a linear term, and this is a constant term, as you can see it here. So if you understand how to do quadratic case, Q is the same thing. So go to the click anywhere on the curve, go to the polynomial and the degree of 3, 4, or 5, or 6. I think like a 6 is the maximum. Yeah. So cube, okay. And how we do the same thing. LINEST, known y values, and known x values. Hat to use a linear part, quadratic part, and the cubic part. You get all the quotient in order of in the descending order of degree. So cube quotient is 0.0778. A quadratic quotient is minus 1.354, and so on. Okay. So that's how we do it with spreadsheet. Okay, so next time I'm going to explain how to do the same thing in Geogebra. So I'm going to move to Geogebra, which is actually this one. Okay, so here I just already put a set of data here. So this is like a 1, when x is 1, y is 2, when x is 4, y is 5, when x is 9, y is -1, and so on. Okay, so it's a set notation, and each coordinate represents the input and output of the functions. So this is going to be something like this. And to find the line of best fit, one thing you can do is, let's say it's fx, or let's say gx. You can use a FitPoly. And FitPoly function gives, you need the input. The input is a set of data in L1, okay? And you're gonna use the linear degree. Then you're gonna get the line of best curve. Minus 0.3577 plus 4.63. Does it equal to the one we had? Right? Should be same. Okay. Likewise, you can also have a quadratic best fit poly L2 on L1 with second degree, and you get the best quadratic curve closest to the points. And finally, the cube one is already put it here, which is this. Okay, so that's how we do it with the GeoGebra. The hard part is actually the inputting the data in this way, which is kind of not easy to type. But once you found it, you can just use a FitPoly function. Okay, next, we are going to the GeoGebra. So for the GeoGebra, you have to input the data table like this. How do we do this? So I just forget about this. For example, you already have like this set. Maybe I can copy this and put it here like this. Then you're gonna get the table as below. Now, to find the line of best fit, you wanna type in like y2. y2 is similar. So approximation y2 can be modeled by ax2 plus b. So this is going to give you the line of best fit. Okay, so you have to use, so the model is y2 and x2 approximated by the line. Okay, if you want to find the best quadratic curve, you just need to change to quadratic function like this. Oops. X2 plus C, and you get this. Okay. If you want to have more, the cube term, AX2 cube plus. This is not good because this A is same, so I have to change to B and change this to C, and this is going to be D for the best curve. If we omit D, it's going to be the cube that goes through the origin and so on. So the Desmos has a very flexible method to have a model. So I can have a different kind of model. Maybe I can model this one using like a sine function, like this. So this is going to be the best sine curve representing the data points. Like I can make it like x2 divided by c, b, like c plus d. This is なんだこれは Maybe this was too complicated. The value of b is very bad. Well, I guess it's because of by choosing b small, this is going to have like a very, very high frequency. High frequency cause the graph looks like this. So maybe I should have some limit to the b, or maybe I should just eliminate b. Yeah. Okay, so you can model something like this. We can also model it using exponential function as well. So how do we make it like some number times e to the power of r times x2 plus c. Like, yeah, so generate any model you want to apply, then it's going to give you the best parameter to fit to the data. So that's how we do it with the Desmos. Okay, so that's all for today. Thank you.